And I took advantage of a lot of cool programs here while I was a student. Like, for example, Dr. Fox offering me that independent study making a guitar amplifier was awesome. It was a lot of fun. And incidentally, a lot of engineers happen to be musicians. So I don't want to say it gave me a leg up, but it definitely gave me something to talk about. I also took scuba diving with Paul Lord. I don't know if you guys know they have that here, but it doesn't cost too much to do it. Maybe it's an extra $50 or so, but taking that scuba class actually helped get my career started, which, speaking of which, if you guys are all about to graduate, I'm sure you can relate to the fish in these bags here, where maybe you're about to get a physics degree and you're asking yourselves, now what? That was me 6 years ago. I was in your position. I was looking at probably Luke D'Imperio giving a similar presentation about similar stuff, and I was thinking to myself, what the heck am I going to do when I get out of here? So, I went to the career development office and I mentioned to them, I'm about to get a degree in physics. I don't really know what sort of careers there are or even what sort of fields I could go into. I'm about to get this degree. I have this education, but I'm not really sure how to apply it or what I can do with it. And the person at the desk there just goes, oh, physics. Oof. And they weren't able to really help out so much. But, if you don't necessarily have something lined up right out of school, don't get discouraged. It's going to happen. It doesn't happen immediately. So, for the first year and a half or so after graduating, I ended up serving tables at a restaurant, which was a lot of fun. It was cool. It taught me how to multitask and work quickly and prioritize. But after a while, yeah, of course, it doesn't want to go to the next slide. There we go. After a while, I finally got my big break. And a quote I really relate to here is, luck is when preparation meets opportunity. So I ended up getting my introduction to the career field by botching an oil change, probably the least likely scenario with the least likely people to get me involved in the field. I was doing an oil change in my family's barn and I forgot to get a filter. So drain all the oil out, and now I have a car with no oil in it and no filter, so I got to borrow my dad's Jeep. I end up going to the auto parts store, and me being the chatty person that I am, I end up talking to the woman at the countertop there for a while, and she's complaining about the weather because it was somewhere around February. I'm like, well, I actually need the weather to get colder because here's that diversifying the portfolio thing. I need the lakes to freeze over because I'm trying to finish my certification in scuba diving under ice. She's like, where the heck do you do that crazy stuff? So, Oneonta and Cooperstown. I just graduated there recently, but I still hang out with the scuba instructor sometimes. And of course, she went to Oneonta and knew a bunch of people that went here, and she was talking about cow path and the deer path and the old Spanish tavern, which is long gone. It's the Red Jug Pub now. But she was asking me what my degree is and what I do with it. I said, well, I earned a degree in physics. I have a bachelor's in physics, and I'm a server in a restaurant. And she's like, dude, you're in the wrong industry, but it's your lucky day because I happen to work in human resources at this company's CVD equipment. And this is where the quote is applicable. I happen to always carry 15 resumes everywhere that I go in a laptop bag, just ready to rock. Because if I'm looking for a job, I'm looking for a job 24/7. And I'm always ready to drop a resume to anybody who's trying to hire me. So that came in extremely convenient. So I gave her the resumes, I ended up getting the job. And that was my first, my first real career job was here at CVD Equipment Corporation. So what that is they do chemical vapor deposition. When I first read CVD Equipment, I didn't see anything about the facility. I just saw a job opportunity and jumped on it. And I figured, when it said equipment, I thought it was like something along the lines of, construction equipment or heavy equipment or earth moving machinery, or I wasn't quite sure what they did until I looked them up. And I was totally impressed. They do cool, hardcore, small scale nanomaterials. So what this place does is they manipulate that chemical vapor deposition process, which is really a fancy term for condensation. So they'll use vacuum chambers and furnaces and specific chemical blends to effectively just put coatings on stuff. So they'll make carbon nanotubes and graphene and molecular arrays. Some of the stuff I've done with them is they had this big program at GE Aviation where, by the way, I'm from Long Island, New York. I'm like way out on the East End, far from the city. And it was a cool travel opportunity for me. They wanted to do a system for GE Aviation in Delaware. So they sent me out there for 6 months to work on this thing out here. And that's called the Gen 2.4 tow coder. And a tow, T-O-W, is one of these here threads on those spools. So the thread there that they're using, sorry, I'm winded from the cow path. The thread there that we have here is a silicon carbide fiber. And what they do with it after they put this coating on it is they weave it into a material, into a big mat, and effectively impregnate it into a ceramic. So the material that they wind up with is called the ceramic matrix composite. And it's almost very similar to a fiberglass, how they'll have, a woven mat, soak it in some kind of epoxy or something, and then you kind of wind up with the best of both worlds with a couple of different materials where you have favorable properties of the fiberglass mat, in the case of fiberglass, and favorable properties of the epoxy itself. So the ceramic that they're using alone is kind of brittle and it breaks easily, but when they impregnate this material into it and they have that woven mat, it kind of gives it a little bit of give, and it toughens it up a whole lot, and it's extremely heat resistant. And that ceramic matrix composite stuff, which almost looks like black porcelain, it's not impressive to see it. But what they're doing with that is they're using that in applications where they need something that's very lightweight, very resilient to mechanical stress, and very resilient to heat. So GE Aviation out there is replacing their turbine blades and combustion chambers and a lot of internal components in their big jet engines with this new material they're using, and it's replacing titanium alloys because, again, it's a lot lighter, it's a lot more heat resilient, it's stronger, and because it's lighter, they have savings on the fuel and it's more efficient. And their mean time between maintenance, it lets them go, longer hours without having to stop the plane and tear the engine down and do maintenance work on it. So I could really not find some great images on this. I got subtitles in French here, but there's supposed to be a secondary vacuum chamber on the top of this one. So you have 2 of these big vacuum chambers connected by a pipe in here, and that's the reaction chamber itself. So these vacuum chambers are going to contain a bunch of these here spools of the silicon carbide. And the silicon carbide fiber is going to spool down from the top, where all the actual fiber itself is, down through the reaction chamber to the bottom where it gets spooled back up. And this entire thing, that entire chamber is pressurized down to just a couple of millionths of an atmosphere. It's a pretty hardcore vacuum. And it's been a couple of years since I've worked on this, but I want to say they heated the reactor chamber to 1,200 degrees C. So it's pretty hot. The benefit of getting the vacuum down, though, is because there's no atmosphere in the vacuum, nothing can actually burn up or oxidize. So you can get this stuff real hot and kind of manipulate these chemical processes to get those coatings on. So that was super cool. Unfortunately, I didn't actually get to stick around at the company long enough to see this stuff get applied. I just got to work on the system there. So my position at CVD Equipment was a systems test technician. It was a really good introduction to the field because with a bachelor's in physics, I didn't get as many, Dr. Fox's circuits class was cool and advanced circuits as an independent study was good, but I didn't get as much hands-on experience as I would have liked to with, basic test equipment, multimeters, voltmeters, oscilloscopes. And this was a good start in my career because it was a fairly basic introduction to electrical systems and vacuum systems and stuff. So most of my tasking would be stuff like, I'd get an electrical schematic and I'd have to go in with a multimeter and just verify, this wire goes from point A to point B. If it doesn't, that's when the fun part begins because I get to troubleshoot where the stuff actually goes, and if something's not working properly, why isn't this working properly? So there's all sorts of different aspects of these systems. I've got electrical sensors and transducers everywhere that are monitoring temperatures, monitoring pressures, monitoring the flow rate of various gases for the processes here. There's strain gauges on all of these fibers because they have to have a certain tension on them, and if you pull it too hard, it's going to break. So that's what these guys are. They're not just pulleys, they're just strain gauges trying to manipulate the tension and keep it within a certain tolerance there. And because it's under a vacuum, that complicates everything because in order to spool these things up and despool them, you can't just shove a shaft of a motor in through the vacuum because then you compromise the seal of the chamber itself. So you have to, we we magnetically coupled everything. So you'd effectively have a magnet on one side of the vacuum chamber and a magnet on the other, and that enables you to have mechanical coupling without compromising the seal of the vacuum there. Another super cool system I worked on is the CVD VP200. That machine is massive, by the way. I mean, a human being's only about as tall as this, so this goes up pretty high. What these guys do, totally separate from GE Aviation and doing their CMC, the matrix composites, and separate from the turbine engines and stuff. This guy is designed to run processes for medical prosthetics. So I don't know if you ever looked at a bone up close, but it's not necessarily smooth. It's not perfectly solid. It's porous like a sponge. And if you try and give somebody a prosthetic bone, their immune system may or may not accept it. The immune system may reject it. So they found that by coating these prosthetic bones with a tantalum coating, the immune system is a lot more likely to be receptive to the new prosthetic. So these guys actually evaporate tantalum, which is a fairly heavy and dense metal, and then redeposit, because of the CVD process, just kind of, it's effectively condensation. It puts a uniform coating over this, prosthetic bone. So that was super cool. Gets down to a very low pressure, gets very hot. Again, it's got to effectively evaporate a really heavy and dense metal. So, we're talking about some hardcore stuff. Unfortunately, they didn't pay me enough, so I wasn't there very long. But it was all good because that's when I found my next opportunity at Collins Aerospace. And again, talking about diversifying the portfolio where, all the academic stuff is great, but sometimes they might want to look at some extracurricular activities. Before I got my job at Collins Aerospace, while I was working at CVD, I applied to get my ham radio license, which is still totally a thing. I actually still keep in touch with some of my old coworkers from my previous jobs via amateur radio. So this is just another one of those things that came up during my interview process. The director of research and development asked what sort of stuff I like to work on, on my own. Am I actually passionate about this field, or do I just want a job that pays well? I'm very much interested in this field, and I really enjoy what I'm doing with it. So I told them about the rotating speaker and how I kind of tinker with my guitar amplifiers and stuff on the side. And then, I work with radios and electronics and electronic filters and, making sure that maybe I'm not transmitting harmonics on a certain frequency that I'm not supposed to be transmitting on. And that sort of thing apparently tickled their fancy, and I was brought into Collins Aerospace as a research and development engineer. So this facility was in Bohemia, New York. And very interesting because they did interior aircraft lighting, which I never really gave too much thought. I'm sure all of you guys have been on planes before, but I doubt you've really given much thought into every hardware component configuration, hardware configuration item that's on the plane. And it's very intricate stuff, and there's all sorts of requirements to meet. Everything has to be flame proof. If anything burns, the smoke can't be toxic. It has to meet very rigorous EMI standards, electromagnetic interference. So it has to accept certain interferences of certain frequencies and certain amplitudes, and it can't fail. Also, it can't be emitting any electromagnetic waves that might interfere with anything in the cockpit or the avionics or the communications equipment. So I've got a little demo here that was in and a meme. Some of the stuff that we had set up in our cafeteria. One of their best-selling products was called the Flex Light. I'll get into that in a second. You've probably seen stuff like it on Amazon. It's really just like a flexible LED strip, but the thing that makes it innovative is that it's certified for aerospace and aviation applications. For dimming LEDs, you can't just turn the voltage down and dim the LED down, because if you turn the voltage down on an LED, there's actually a color shift. So it'll go from like white towards yellow, and it loses its calibration point. So they effectively flicker the light very fast. If you want to have a light, say maybe 50% of its normal amplitude, you would duty cycle it to have it on 50% of the time and off 50% of the time. And that's called pulse width modulation. Sorry, I don't have a picture of that waveform here, but that's besides the point. The takeaway is this thing does pulse width modulation without actually emitting any interference that's going to interfere with the avionics in the cockpit. Down in the bottom right, I've got an edge-lit LED panel. I'm going to get into that later. Me and my buddy Jameson designed this. This is just sort of like a 3D printed array. It's made with silicone, just clear, flexible silicone. The cool thing about that is it's a total internal reflection optic. Let me get into that in a further slide. Okay, so here's a close-up of the flex light. This is a flexible printed circuit board with surface mount LEDs. Each of these right here are current drivers, just keeping the LEDs going at a constant current so that they don't lose their brightness or lose their color point. The cool thing about this guy is it does multiple different colors and they're all calibrated color points. I don't know if you've ever seen this, but this is the CIE 1937 color chart. And if you've taken General Physics 1, does black body radiation? Maybe General Physics 2?
General Physics 3.
Okay. So I've got a black body radiation curve here, and effectively that's just the color and the wavelength of literally a black body at a certain temperature. And that's how we categorize the colors of a white LED. So if you see a white LED and it's kind of a harsh white, it's almost kind of blue, and maybe they'll spec it at, like, you know, you see the number 6000K. I don't know if you ever gone shopping for light bulbs or something, but you see 3700K or 6000K, and that corresponds to a temperature that a black body would be emitting the same wavelength at. So a light that's 6500K, it's that harsh white that's almost blue, is reasonably representative of a black body at that temperature at 6500K, or maybe something like a 3700K that's like a nice orangey yellow candle light is, you know, what you'd see for something around that temperature. So that's how we categorize these guys. And a way that we manipulate it in a practical commercial sense for aerospace is actually manipulating the body's circadian rhythm. So for really long international flights, if you guys have ever gone abroad or something to a different time zone, it sucks because you have jet lag. And you can actually kind of manipulate the body's circadian rhythm by tuning the lights. So what we do is if they're going to be going somewhere where it's going to be morning when they land, we'll kind of slowly tune the color of the lights to be more of that 6000, 6500K, to be this harsh white that's almost blue that kind of wakes everybody up and gets you, ready to wake up in the morning. Or if they're going to be going somewhere where the sun's setting by the time they land, we'll slowly adjust the color to bring the color temperature down and get you more of that orangey yellow sunset kind of vibe. And it like tricks your body into thinking that it's a different time of day. Yeah, interesting stuff. Another cool thing that we did at Collins. Weight on an aircraft is critical. The big aerospace companies are always trying to find ways to reduce the weight of literally everything on the plane without compromising anything else. I think it was JetBlue Airlines recently that decided to take their salads that they gave all the passengers and remove one olive. They went from having 5 olives per person to having 4 olives per person, and it saved them like $2.7 million a year in fuel costs just taking 1 olive from every passenger. Because over time and over a long history of flights, that weight savings can result in an enormous amount of money saved in fuel, even if it's just something so insignificant as just 1 olive. It adds up over time. So the director of research and development wanted my buddy Jameson and I to investigate the idea of replacing what would normally be 3 reading lights up here. You'd have one per, or in this row where you have 3 seats, you'd have 1 reading light per passenger. And that's usually some variation of a ball joint. I'm sure you've all probably been on a plane and seen these things before, but there's a light in a ball joint and you can kind of wiggle it around and point it wherever you like. But those are all components that are made out of plastic. The plastic has to get manufactured somewhere. It has to get injection molded, and after it gets injection molded, you got to have somebody on the assembly line assembling it. That gets passed down the line, and you have somebody testing it. Whereas there's a torque spec. How hard do I have to move this light to move it? Is it too hard? Is it too easy? Does it wiggle around by itself? If it fails, it's got to go all the way back to the beginning and get rebuilt and retested again. And this stuff can get kind of costly, especially when you're using plastics that are aerospace grade and have to meet all these requirements for flame, smoke, and tox, where it can't burn, it can't produce any smoke that's toxic. There's even a fungus requirement where it has to be somewhat resilient for fungus growing on it over time in case it's in a humid environment. So we decided to investigate, as far as weight savings go, what if we were to replace those 3 reading lights with one singular fixture that has no moving parts? Effectively, the reading light fixture, or the total reading light fixtures per row of seats, would at that point only weigh 33% of what it used to weigh, because there's 1 light now instead of 3. And the way we do that is effectively making a projector. So here's a printed circuit board, and you can see how we have an array of micro LEDs. Each one of those little LEDs is only about 1 millimeter square. They're tiny. I had to solder all of them underneath a microscope. It was very difficult. So by selectively illuminating a few of these LEDs over the entire matrix area, you can choose what area on the seats is going to become illuminated. So by just choosing these 3 little clusters of LEDs, I have 1 little spot on each of the seats, or I could illuminate a large area here and have the whole area of the seats illuminated. And this just goes to show you that you can do a circle too. But here's sort of a breakdown of the light itself, from over here. So it's fairly simple. We've just got our printed circuit board here with all the LEDs and the circuit drivers and everything for them. There's a heat sink on the back because the LEDs get hot. Initially, the housing was 3D printed. This is probably going to become injection molded, which is cool because it's just the one part instead of having the whole ball joint injection molded that's got to get injected and assembled and tested for all that torque spec and everything. And then just a lens and a little cover to make it look nice. So, this is nice as far as the manufacturing and testing aspect goes, because we're negating a lot of procedures where they'd have to have all these people involved. There's all these potential to have failures. There's all the material that's got to get built. And then there's the possibility that, you have stuff that moves on the plane. It could fail in the future. You'll have to rip it out. And there's also the weight as well. So there's a lot of benefits of going from the 3 separate ball joint reading lights to the micro LED reading light. Collins Aerospace sent me to Germany in 2018 to go display this at a trade show where everybody's got a booth and they're showing off all their newest innovations. Boeing was there, Airbus was there, Safran was there, and then Collins Aerospace, which was Rockwell Collins at the time, was there. I ended up coming home with the trophy for the Innovation Award with the micro LED reading light. Everybody loved it. Boeing wants it, Airbus wants it, and they're funding a lot of more development in that field. And I think that's going to be the next big thing. It's very likely that within the next few years, you're going to get on a plane and the row is only going to have 1 reading light and nothing moves, except the beam. Another cool thing that we had to work on there, this goes back to that funky thing that said Collins Aerospace, where I talked about the silicone and the Edgelit LED panel. Airbus wanted us to make a light fixture for them with only a certain amount of electrical power draw, and had to be a certain thickness. It had to be very thin. So usually LED lights like these go, maybe not these are fluorescent, but for a rectangular LED panel, you can just have LEDs all over the place emitting, and that's totally fine. But we don't have the availability to do that. So we kind of copied technology from maybe computer monitors and TV monitors where they only light the edge of the panel. So instead of having LEDs sort of all over the place that are shining directly out of the panel, they're only along the edge. And you wind up with this principle called total internal reflection. How many of you, this is just the development of that little horseshoe panel that we saw there. It kind of started out as like an arts and crafts project where we just cut that pattern out of paper and slapped it all together. Looked nice when we were done. Yeah, so there it is up in our mock-up. Collins has a couple of mock-ups there. There's a 737 mock-up and an Airbus A330 mock-up. And these are effectively just make-believe sections of an airplane that are made out of styrofoam. So we can just put all this stuff together and test how it looks. Airbus CEOs would come in to inspect it. Boeing CEOs would come in to inspect it and just kind of see how these new concepts look. And it gives us a test space without having to actually, own a whole entire aircraft. Back to that LED panel. There it is. So the technology that we use is an Edgelit panel. So this This technique is exactly what's going on in your computer monitors that you have in front of you right now. Again, instead of having LEDs all over the place that are emitting perpendicular to the surface, we use a row of LEDs along the edge of the material. And we wind up with this phenomenon called total internal reflection. Because the index of refraction between the light guide, and that's this thing, by the way, between that medium and the air is so great, and the angle of incidence is not enough for the light to escape, it ends up just bouncing around on the inside of this light guide, and that's why they call it total internal reflection. So all of these rays that are emitted from the LED are kind of just trapped inside the panel, and they go right from one end to the other without actually coming out of the panel. But that on its own doesn't actually do anything for us, because effectively the light's just bouncing back and forth on the inside of this thing, and it's not coming out and illuminating anything. So that's where we had to do this thing called science. You have to disrupt the medium between, in this case, it's probably going to be some sort of blend of acrylic or polycarb. So you have to disrupt the boundary layer in between the medium of the acrylic and the air. So that's what you see on this guy right here. You'll see there's like dots and stuff over here, and there's dots on that guy over there, because that is what's disrupting the medium, again, between the light guide and the air. So when it hits that dot, and there's a bunch of different ways you can do this. You can have it either etched or scratched into the panel. You could have it silkscreen printed on there. You could have the entire thing injection molded and just mold it so that it comes out with that pattern on it. But calculating the pattern is really difficult, because if we're going to be illuminating this thing from either side, you can't see the whole thing on this picture, I'm sorry about that, but we're going to have a bunch of LEDs on one side of the panel and a bunch of LEDs on the other. So as you're controllably letting light out of the panel, it's going to be emitting perpendicular to the surface, which is what we want. But as we get farther from the source, we start running out of light. So we have to make the dots bigger towards the center of the panel and smaller towards the source of the light. Here, we got plenty of light to work with. The LEDs are right there. But in the middle of the panel, and we're far from the source, we're going to have to make that disruption pattern a little more prevalent to let out more of the light, because there's just less of it as we get farther from the source. So that involved a lot of math. And it was a lot of fun. Anyway, the next step on this guy was we had to make sure that it met all of those aerospace requirements, that, flame, smoke, and toxicity and stuff. It can't burn, it can't produce smoke, and it can't produce any toxic vapors if you burn it. And Airbus wanted it to be flexible too. So I can't just go and use acrylic or polycarbonate or some sort of plastic that plays nice with light and let light go right through it. I had to choose something difficult like silicone. So we ended up partnering with Dow Corning to produce a specific blend of silicone with us that was flame retardant, so it wouldn't burn, and also had a high optical transmissivity. And it didn't just have to have high optical transmissivity, it had to have an even transmissivity at all the wavelengths we wanted to use. Airbus doesn't just want to use white, that's boring. We got to use all sorts of different stuff. They might want to change it later down the line, and we can't let this medium that the light's going through attenuate certain wavelengths and then kind of wash the light out and have it be dimmer at one color than another. I think I have another slide on this. Nope. Sorry. So me and the R&D crew ended up getting a patent on that thing, because nobody had ever decided to make a flexible light guide before. And it was pretty cool. So here's the lab I got to work in there. Let's see, I got some multimeters here and a oscilloscope over there. All sorts of test equipment for the micro LED reading light. I'm looking underneath the microscope here. Those are all the LEDs on my fingertip, showing you how small those guys are. So I'd be soldering in the lab. I don't have my stereo microscope in here, but I'd be using hot air to solder those things underneath the microscope, with tweezers, because each one of those is a millimeter square. Pretty cool stuff. I thought this was kind of funny. We all showed up in the same outfit one day in the lab. Engineers kind of have this thing where they all do this cookie cutter thing where they all wear the same outfits. Anyway, same scenario as the first job. I was accomplishing all these things for him, and I didn't see any pay raises or anything coming anytime soon. I was living with my parents on Long Island, and Eastern Long Island, as you guys might know, is really expensive, and there was just no hope of me moving out. So I looked to the north, and I found General Dynamics in Pittsfield. So I tossed my hat in the ring. Again, I showed up to one of these career fairs with a giant stack of resumes, ready to give them out to anybody who wants one. And I ended up being offered the job title of Senior Electrical Engineer. I told the recruiter when they offered me that there's something I really got to clarify with you guys. I never studied electrical engineering. But, so if they want to give me that title, it's on you guys, but we're just clear that we communicated this before. And back to that thing about not getting discouraged. If you see a job posting that seems like they're being picky, they want a master's degree and 10 years experience, apply to it anyway, because, maybe they'll take what they can get, which is what happened in my case. Super cool, because when I got to Pittsfield, at the new job at General Dynamics, I got to work on the fire control system for ballistic nuclear submarines. So here's a Trident D5 submarine-launched ballistic missile. That thing is 130,000 pounds, and it launches out of the submarine like nothing, like a Nerf dart. Oh, by the way, everything I'm telling you guys about this thing is all in Wikipedia. I'm neither confirming nor denying it. I'm just telling you stuff that's plain public knowledge, and none of it's actually from the company. So that thing's 130,000 pounds, and it just pops out of the submarine like nothing. It's got a maximum range of about 7,500 miles, and I think a maximum capacity up in the nose cone there of 14 different nuclear warheads, each of which is independently targetable. So you could send these 14 nuclear missiles up, and there they all are down there. That's what's in the nose cone. Not necessarily 14 of them in that case, but anywhere between I think 4 and 14, maybe. And these guys are all called MIRVs, and that's a multiple independently targetable reentry vehicle. So each of these guys can go hit a different target. So from launching this thing out of the submarine, the rocket only fires for a fraction of the flight. By the time it gets up towards the edge of the atmosphere, the rocket's already expended all of its fuel. And for the remainder of the entire ballistic path here, it is literally ballistic. So you can only control the projectiles in flight for maybe a third of its entire trajectory. So it's critical that the guidance system is ridiculously accurate. So again, all public knowledge stuff, nothing proprietary or government secret. These things use two different types of guidance systems working together to constantly correct the path of it in midair. So there's an inertial guidance system and an astral guidance system. The inertial guidance system originally had electric gyroscopes that were spun up to thousands of RPM, and it took a couple of minutes before you could launch a missile because you had to literally spin up the guidance system to get this thing going to a proper RPM to where it's going to reach its stability. And then that gyro is just kind of on a couple of gimbals, and it's constantly correcting itself. It integrates the force applied to it over the time the force is applied, and it pretty much knows where it is based on that, based on where you launched it from. So in pair with the inertial guidance system there, that's all gyros. And by now, we're kind of phasing out all those gyros with the moving parts again. And we're going to what they call ring laser gyros. So there's a laser that fires pretty much in a ring based on a bunch of mirrors that are all like micro electrical mechanical switches. And any kind of force applied is going to make these mirrors move and deflect the beam. And based on the beam deflection, they can calculate the force that's applied over the time that it's applied and how far it traveled and at what velocity. That is constantly corrected with a camera in the nose cone, specifically trained to look for one particular star. And it's supposed to know exactly where that one star is at every point of its entire trajectory up until it lets those MIRVs go. So that camera looking at the star out there is constantly comparing its results on the navigation system to the inertial navigation system, and they kind of work out a solution for the position based on the two values. I can't tell you exactly how they're favored, but there's the two guidance systems out there. And then once it gets to the edge of the atmosphere, it just kind of lets all these things go, and all of them fall down to their independent targets. So each one of those missiles could carry, again, I think up to 14 nuclear warheads. They can all pick their own targets, and there's 24 of those missiles on each ballistic missile submarine. So each submarine could, in theory, like wipe out multiple countries. So it's critical that all of this stuff works. That's the trigger that actually launches the nuclear missiles. I went down to Cape Canaveral 2 weeks ago and got to actually pull the trigger on one of those. Super cool. Just like you see in the movies, how they have to read the codes and open a lock and get their keys out, turn the key at the same time. Ultimately, they end up opening a cabinet and that triggers in it, and that's what's going to launch the missile. It's obviously a simulator and it didn't launch any nuclear missiles, but it was super cool. So I started working at General Dynamics, I guess, in 2019. So I've been there for about 2.5 years. COVID happened right in the middle of it. And while I was working there, by the way, the cool thing about the government contract jobs is they do 9-hour days, which might sound long, but you have every other Friday off. So 3-day weekends every other weekend. I would go road trip somewhere. I'd go up to Vermont, I'd go out to New York, go to Albany, Boston, wherever. And I ended up with all this free time on my hands because of the quarantine. And I found out in Saratoga Springs, they do this super cool thing called helicopter training. So I spent some of the free time in quarantine going out to get my helicopter pilot license, kind of just for kicks. And while I was up there with my flight instructor over Saratoga Springs, see this big concrete dome that we always use as a navigational waypoint. And you're constantly picking out stuff that stands out, like water towers and big secret government concrete domes and things that stand out to use as waypoints in case your GPS fails or something, because that could totally happen. So while we're out there doing that, we're flying over this big dome. And I ask him, exactly what that is. So he tells me that's the Navy Nuclear Power Training Unit called Knowles Atomic Power Laboratory, or CAPL. And that's where the Navy develops new nuclear reactors, and they also train the Navy personnel that are going to be serving on submarines and aircraft carriers, how exactly to operate the reactor, what to do in the event of a failure, and just kind of train the guys that are new and enlisted into how to operate these things. So I'm leaving General Dynamics in 2 days. I'm already in vacation mode. And then my next step is going to be going out to work at the Navy Nuclear Power Lab. And, this all happened just because I was doing something completely irrelevant and just flew over it and happened to ask the question. And my flight instructor had a degree in physics too. I asked him how we've been doing this for a whole year together, and he never thought to mention the nuclear lab 4 miles away from the airport that's been there the entire time. So that is where my career is leading me right now. I'm all packed up and moved. I live in Saratoga now. Things are pretty good. And the takeaway I want to present here is I was not necessarily the ideal student when I was in Oneonta, and I was very confused when I was graduating. I didn't necessarily know what I was going to do. I had no idea what career paths were even out there. And now, I spend my weekends flying helicopters, and I'm going to go work at the Navy Nuclear Lab. So, if you guys are stressing about things, don't, because it'll all work out in time. It's not going to happen immediately, but everything will totally work out for you. And that's it. That's where I am now.
So you're going to work at CAPL?
Yes. You familiar?
That's where my brother works and my dad worked for many years.
Yep. When I started talking to my flight instructor about this, he goes, "Oh yeah, Heather's brother works there." See, this goes back to the luck is when opportunity meets preparedness. My flight instructor mentioned that the woman that owns the entire helicopter company has a brother that works at the facility. And again, I'm like, well, gee, guess who's got a stack of resumes ready to rock at a moment's notice? This guy. So he was able to pass the resume on, and because of some seemingly irrelevant hobby, another connection was made, and it just facilitated the whole future. Again.
What's your title going to be there?
Advanced electrical engineer.
Yes.
Which again, I think is interesting because I never studied electrical engineering. But that's the company's decision, and that's what they thought was cool.
Yeah. Anybody have questions over there? Anybody?
I have about a dozen. So
Sure.
Everyone can interrupt at any time. Did you get your ham license?
Yes.
And how was that?
Stupid easy.
Okay.
They would show me an electrical circuit, and there'd be some basic circuit with a light bulb and a current limiting resistor or something, and they'd ask a question like, the input voltage is 12 volts and the current here is I. Which one of these components is the resistor? it can't be this easy. Really? This is it? And the test costs $14, so it's really not a big deal. They might trip you up on some questions like, if you have a amateur extra license, which of these frequency bands are you allowed to transmit in? And that stuff you have to just memorize. There's no way to really learn it. But I mean, the actual electrical stuff, it's designed so that people who don't have a strong background in science or electronics can actually go get these licenses. So it's really not very in-depth.
We have an alum whose father was a professor here who would love to start a hand club with everybody.
I would love to
here.
see one.
Yeah, okay, interesting.
Yeah.
And Put it on the list.
I've made all sorts of connections through work there. I still keep in touch with people from CVD equipment, people from Rockwell Collins over radio. Some of the guys at General Dynamics were kind enough to give me a log periodic antenna. So that sort of antenna kind of looks like a Christmas tree. You've probably seen like TV antennas on top of people's houses that look like that. And the advantage that they have there is that they present a 50 ohm impedance to a broad spectrum of wavelengths. So, I have an antenna that's good for a 2-meter wave down to a 35 centimeter wave, and it's going to be a 50 ohm impedance across those bands, which is cool because usually you get a half wave dipole or something, and it's only really resonant on one band.
The light design for the aircraft, replacing 3 sockets with one. Did you lose changing directionality with that, or is it preserved?
No, you can still selectively illuminate those clusters of LEDs. So depending on where you want the light to go, that one light can effectively do the entire area of 3 seats. So depending on which area you want to illuminate, you can pick which little cluster of those micro LEDs actually gets powered on. And they're still kind of toying with how to do that, whether it's going to be a joystick or a touch screen, or whether you just have a couple of buttons with, presets that you can only adjust so much. So they're trying to figure that out. Anything that they do has to be resilient because it's, you got to put up with like stupid people or babies kicking stuff on planes, and it's got to be fairly rugged and resilient.
Engineering for stupid people.
No, really. Some people go on there and, vandalism is a thing and you wind up with stuff like that.
Did you take optics while you were here?
No.
Do you regret that?
Yeah, there's a lot more classes I wish I took here. I feel like even though I did my 4 years and had one more semester here, I really didn't have enough time to study everything that I wanted to study. At the time, I went to school when I was 18, and I was maybe not fully prepared and mature enough to get into an undergrad program at the time. I kind of struggled through things, and it was all a lot going on all at once. I grew up in a fairly protective household, so coming out here to live on my own and just have all of this freedom all at once is, went about as well as you could expect it to go.
What kind of CAD program do you use to lay out your PCBs?
Actually, I use Express PCB, which is a totally free program. You guys can download it to make printed circuit boards there.
We're doing Eagle down the hall. Can you compare the two? Like, would you recommend this one over Eagle? Or
I haven't used Eagle before, but what I like about PCB is that there's a PCB fabrication house attached to the program. So Express PCB is a program where you can draw your circuit boards. I think they let you draw up to like 14 layers. So you can have all sorts of components and all sorts of layers. And when you're done, you can just go up and click File, Order, and that place will build you those printed circuit boards for a fairly reasonable price. It's not expensive. And all the projects I did at Collins Aerospace in research and development, I just went and got this free open source program, drew up my PCBs, and ordered them, and had them in like 2 days. So it wasn't bad. I use PCB Artist at General Dynamics, but they don't let me have as much flexibility with design. They're really more like supporting legacy programs. I mean, the fire control system for the Trident D5 goes back to like the 1970s. So a lot of what I'm doing there was pretty much power conversion design. A lot of like AC to DC power supplies, and I would get requirements from maybe, say Lockheed is going to be making a missile, and they say they're going to have these sorts of loads. We need you to provide this voltage at this current, and the voltage is allowed to fluctuate between these levels. And you have to be able to dissipate this much heat in your power supply. And we would kind of work with designs on that. And I didn't get to do as much really in-depth electrical engineering as I wanted. And that's when I go to the Navy Nuclear Lab. Also, the Berkshires can kind of be a sketch area. So there's that, the geography aspect.
do you have security clearance?
Yes, right now I have a secret security clearance through the Department of Defense, and that is what General Dynamics got me. I also need a separate security clearance to work at Knowles Atomic Power Laboratory, but because of the nature of the work, that's actually through the Department of Energy, and they do a different structure. They don't just do they don't do secret and top secret. They do their lower level one is confidential, and then I think they have secret and top secret. So my clearance from the Department of Defense pretty much transfers over to meet the same requirements as the confidential clearance for the Department of Energy. So for a brief period, until maybe a year and a half later, my secret clearance to the DoD lapses, I'll have the DoD clearance and the Department of Energy clearance, which is cool because then I'm cleared to work on nuclear missiles and nuclear reactors. Yeah. So that was only like 2 or 3 questions. I guess you have.
Yeah, no, right.
Wait, I got one. Can you hear
Yes.
me?
Yeah, go ahead there.
Okay. I have like a few questions, but they're all somewhat similar, so I'm going to try to make it into one sentence. We'll see how that works. So all of the jobs that you've taken, they seem pretty like diverse, like they're pretty different. Which one of those jobs do you think you enjoyed working at the most? And do you think that does the journey like end at this new naval power plant job, or do you think you're gonna keep moving?
Okay, those are great questions. I really enjoyed my time at Collins Aerospace the most. That was sort of like being in an electronics playroom. You know, I got to go in and they gave me a lot of projects where I'd have design creativity where I reported directly to the director of research and development. And he would come in and just kind of drop a concept on my buddy Jameson and I. We were effectively the whole R&D team. We would just get like a gentle nudge in a direction and get to just go and explore, you know, what concepts work and what concepts don't. And, you know, we did a lot more in this necessarily than just lights. I got to go on a lot of cool travel for that. They sent me to Milwaukee, Wisconsin. They sent me to Tucson, Arizona for a week by mistake. That was fun. I got to the facility there and there was no work to do. And they were like, well, the company already sent you here and they pay you by the day. So just go see the sites for a while. So I just went around and saw the Southwest for a bit. For a whole week, I basically went on vacation. They sent me up to United Technologies has a corporate research and development facility in East Hartford, Connecticut. So I got to go up there a couple of times and talk to some PhD guys with fellowships out there about lenses for the micro LED reading light and how to kind of best apply that micro LED reading light principle. So what they were doing out there at the UTC R&D headquarters was 3D printing optics. Actually, they've got 3D printers with a high enough resolution. I mean, you still need to polish the material after you 3D print it, but they're printing optics and lenses, and it's not just one singular lens that they'd be printing. Maybe in the middle of the printing process, they would change the head on the printer and then start printing with a different material. So you'll end up with one lens, but there's different areas inside that material that are going to be of a different index of refraction. So you could effectively have the properties of a whole stack of lenses effectively condensed down into just this one lens, because you can manipulate which area in it is going to have a specific index of refraction. And that opens up a whole lot of cool possibilities. So working there was a lot of fun, again, because of this design freedom. Going up to UTC's R&D headquarters, we got to play with a lot of really cool stuff like laser sintering, additive manufacturing, which is similar to 3D printing, but they'd have like a substrate of metal powder and they would just beam a laser down on it and melt it and let it cool down again. And then that would kind of harden up into something. So they could make, very intricate heat sinks, for an example, that you can't necessarily like mold or forge or machine because they're going to have complex internal geometries. So they can just build this from the bottom up, effectively 3D printing with metal. Another thing at Collins Aerospace, as far as R&D stuff goes, is falling back onto that concept of the aerospace industry constantly looking for stuff that's more lightweight. Because everything is so weight driven, they might be more interested in a solution that doesn't necessarily seem to be the most practical. For example, to run one of the controllers for a bunch of lights in the aircraft cabin, they just have a little PIC microcontroller. You can get those things on an electronics site for like 75 cents. They're like little effectively like FPGAs, like Arduinos. And they just needed 3.3 volts at a very low power to power those things, but they have 115 volts AC coming in at 400 hertz. And they're interested in seeing how they could step down the 400 hertz, 115 volt AC down to 3.3 volts DC. And their biggest concern is weight and electric isolation. And, you know, us being a facility that's very centered on lights, you know, I'm hanging with my buddy Jameson and we say, hey, what if we have the 115 volts, power a bunch of LEDs and just shine them at a solar panel? It's horribly inefficient and it's awful, but it's smaller than any AC to DC converter they could get off the shelf. And it provides you that isolation because it's literally optically isolated. There's no electrical connection from the AC side to the DC side. And they bought it. You know, awfully inefficient. You know, it was like 13% efficient. It just threw away lots of it. But because it's, you know, 3.3 volts and it's a couple of milliwatts, you know, what's you know, 77% of a couple of milliwatts, it's not a big deal. They're not really worried about throwing away that energy. What they're really interested in is the lightweight and the electrical isolation. So they went with our concept of driving the microcontroller with shining LEDs at a solar panel.
Andrew, you have another question?
Kinda. So the second like part of that question. So the Naval Nuclear Power Training Unit.
Right?
Do you think like maybe you would go back to like a previous job if they offered better pay, or do you think it's I don't know. I just want to know like what you're planning on doing.
No, you're gonna settle down.
I don't know. I keep trying to settle down, but I would, you know, because these areas have been geographically far away from Long Island, like General Dynamics and the Navy Nuclear Lab are both far from home for me. So in each of these cases, I have to move and relocate for the job. And this is something that you got to take into account when you're looking for jobs too. It's not necessarily just the nature of the work that you're doing and the product that you're working on or the research that you're doing. It's also the area that surrounds the workplace as well. You got to consider the geography too. So I don't know if I'd go back to Long Island. You know, the job was really cool and I loved it there. And more importantly than anything was the director of R&D was a genuinely good leader. He always had our backs. He was always looking out for us. He would always take the R&D crew out to all sorts of like expos and conventions to just learn about the industry and learn about the products. He had a lot to do with us getting the patent on that LED light guide optic. And again, he was a really good leader and he was a good role model. But I have to live on Long Island to work there. And there's a lot of traffic there. It's getting very busy. The taxes are absolutely ridiculous. I can't afford to live out there. So even if they gave me a good position there and a good salary, I don't know if I'd want to put up with the headaches of just living in the area. And it's the same thing for General Dynamics, although the company wasn't necessarily as functional a workplace as Collins was. It's different because it's a government contractor, so it's not necessarily so incentive driven. With Collins Aerospace, you know, the product that they're designing and developing has to work, and they have to be able to get funding to do the research on this, because if the product fails, the company runs out of money and then goes bankrupt and they're gone. General Dynamics, on the other hand, is a government contractor. You know, if they're inefficient and things aren't working well and they're not necessarily producing what the government wants, they just ask for more money and get it. So there's not really an incentive to operate as effectively and produce such high quality output as there is in the private sector. So that's something to consider too. Yeah, I'm going to another government contractor, but you know, this is also critical stuff. So I assume that they take their quality and ethics really seriously. But I don't know if I would go back. Again, General Dynamics in the Berkshires was cool because, you know, I grew up, I became an Eagle Scout, so I'm very outdoor oriented. I did a lot of outdoor stuff here in Oneonta at the Outdoor Adventure Club. I did, you know, ice diving with Paul Lord out in Cooperstown when I could. And the Berkshires are really a good location to kind of take advantage of that. There's a lot of mountains and a lot of trails and stuff around there. There's a handful of lakes I'd pass on the way to work. So there's plenty of opportunities for that stuff. But the area that I lived in was fairly financially downtrodden. So this goes back to like the 1980s where General Electric was there, Sprague Electric was there. They manufactured capacitors. And those two companies alone were massive. Each one of them had like 10,000 employees. So most of the county worked for General Electric and Sprague Electric, making all those components. And when those companies left the area in the 1980s, it sort of left the upper northwest portion of the county kind of downtrodden, and it wasn't fun living there. So I don't think I would go back. Unless they really enticed me. Yes.
Would you be looking to get your PhD in the future?
I don't know. I've been trying for a long time to get my master's in electrical engineering, actually. I think, at this point, with the way that my career is going in the direction it's going in, kind of focusing on aerospace and defense, and then more like applied sciences. I did some research and development type stuff at Collins, but now at this point, it's really more electrically oriented. So I think going for a master's in electrical engineering is a good way to go for me. It's just, where do I go? I keep moving around. I just started an online program recently at Western New England University. And they're out in Springfield, Massachusetts, which if I had stayed in North Adams, Massachusetts, would be about an hour away. So if I wanted to go in and attend a class physically in person, I could, but now that I live in Saratoga, it's a little more difficult. It's all online. And all at the same time, I started taking that class, which was artificial neural networks, by the way, like machine learning and artificial intelligence. I started taking the class, and then General Dynamics sent me down to Cape Canaveral to conduct electromagnetic interference testing on their fire control system. They were concerned that some electromagnetic noise may interfere with some of the equipment there and prevent it from actually either launching missiles when we wanted to launch missiles, or they would make it launch missiles when we don't want to launch missiles. Either way, it's catastrophically bad. So all at the same time, we've got my class starting. I get sent down to Cape Canaveral. I come back from Cape Canaveral, and I'm trying to move to go start the new job in Saratoga. So my apartment's half moved. I'm going down to Florida. I'm coming back. They sent me to the Naval Underwater Warfare Center in Rhode Island, and I'm still trying to get my apartment unpacked, and like all these things happening all at once. Like I might have to withdraw from the class just because I can't sleep at night. I don't have enough time today to eat. It's a lot going on at once, but I don't regret it. It's going in a good direction. It's all for good things, and I need to take this next step. I just might have to delay my master's degree one more semester, and then when everything becomes a little more stable, I can finally start it. And that doesn't really discourage me much. If I try hard enough and long enough, it'll start and it'll happen when the time's right. And they'll help pay for it. Anything else? Yes.
Yeah, so did you have like a specific plan before you graduated from here, like with the degree itself? Also, like what class has helped you the most in like your current, I guess, career path?
I did loosely have a game plan when I was going to graduate here, but it fell through. But it's actually for the best, and it's interesting because 10 years later, it's all coming together. I wanted to join the Navy and work as a reactor engineer on a submarine working on the nuclear reactor. But at the time that I graduated, the president at the time wanted to downsize the military, kind of trim the defense budget, and they were going to start with military officers. And they were going to start with military officers in the Navy nuclear program. I'm like, great. I just finished my degree and my entire career plan just got totally torpedoed. Now, slide number one, now what? And it's interesting though, now that I'm going to the Navy Nuclear Power Lab, because I went to college in 2010 when I graduated high school with the intention, knowingly, that I would go join the Navy and work on reactors for nuclear submarines. So here I am in 2021 going to the Navy Nuclear Lab to work on reactors for submarines, and we're totally full circle.
Also, I was told you were going to be landing in a helicopter here.
Yeah, the weather wasn't quite
By somebody.
great. Yeah, no, it's going to happen soon enough.
I just mentioned that he flies them.
No, that
Yeah,
was
it'll happen soon enough. I want to get out here. I'd love to get a GoPro video. I still have my Oneonta Red Dragon t-shirt. I'm like, I'd love to get a GoPro video flying the helicopter above here in the Red Dragon shirt. It still fits. There's
When
a lot.
you do that, maybe talk to like the campus, PR machine, and maybe they can give you some money.
That's a whole gray area there because the license that I have only allows me to fly like recreationally or, you know, I have a private pilot license, so I can take people flying, I can do all sorts of fun things with it, but I can't legally fly for compensation. I need a commercial license for that. That's probably another, I don't know, $37,000 on top of whatever I already spent, a lot. But if they ask me to volunteer to do it, then everything's fine. And of course I would, because it's fun to begin with. There's a lot of variables to take into account out here. Flying in the mountains can be kind of tricky. It's actually, you're better off doing it when the weather's colder because the air is a lot more dense when it's cold. The rotors themselves get a lot more effective lift because the air is more dense. And then the engine itself, for the same volume of air, there's effectively more air because it's more dense. So the engine is more powerful too. So there's a couple of different ways that this gets better as it gets colder. So maybe in the winter I'll be able to get out here. It's just tough because I think the altitude here is like maybe 2,000 feet above sea level. So we're a lot higher than you actually think you might be.
I just wanted to say that you said something like you weren't the best student. I was self-deprecating. I have to like beg to differ. Even when you're here, I really liked your attitude. Like, I know what you mean. Like maybe like, and I think I say this because a lot of our students, they might struggle with certain aspects of their studies. But sometimes maybe at the end of the day, what's most important are extra qualities. And I always felt like you had those, like this kind of like A, certain fatalism, and B, an optimism. Both kind of put together. And this go for it kind of thing. Like you always had ideas. You're always somebody like, here's a crazy idea. Maybe we can try this, maybe that, And you wouldn't give up, And I think that that made you a good student. And I see you as a success, and I think we're proud of you.
Thank you.
And, I want that to be like a lesson for people too.
Maybe my weakness is that I take on too many things and spread myself too thin, but I'm very enthusiastic about my field, and it's really important. You have to be interested in what you do, you have to like what you do, otherwise you're just going to go through life miserable.
It's interesting, that could be a weakness and a strength.
Yeah. So that's sort of where I'm at right now, is I'm taking on all these things all at once, and I might have to put my master's degree on hold because I just have too many things that I can't handle necessarily all at once. But absolutely worth it, and I appreciate the praise. Thanks. Any other questions, anyone? Bueller?
Anybody online have anything? Any questions? Anybody virtual?
How about Daniel?
Daniel,
Thank you.
I picked on Daniel for not asking questions last time, and I think he's not coming now.
Oh.
So Daniel didn't attend. Daniel is, Valerie, you have to work on him.
I do.
Isn't he in your astronomy?
I didn't take my class.
Oh,
I got him in 2 classes. I could work on it.
okay.
That's different Daniel, maybe.
Oh, not Daniel Ball?
No. Daniel Ball is, he's in wiggle time.
Oh, he's the winner.
Oh.
Yeah.
You missed that.
Wiggle time. I need to really get
We're good.
Before you guys.
Thank you so much.
Absolutely. Thanks so much for having me. It's a pleasure.
Yeah, that was really fantastic. Very inspirational.
Was indeed.
Yeah.
All right.
Yeah, I would love to do